This is CPM Calculus Chapter 4, number 108. So here we have integrals, so let's examine them and consider the multiple tools available we have right now to evaluate them and use the best strategy for each. Okay, after evaluating them, write a description of the method you used. Alright, so part A, here we have 2y minus 3 squared. So we cannot right now do the integral with a binomial squared, but what we can do is expand this first, right? Because that's going to be 2y minus 3 times 2y minus 3 dy. And then we could go ahead and distribute these binomials. So that's 4y squared minus 6y minus 6y plus 9 dy, and that's equal to the integral of 4y squared minus 12y plus 9 dy. Right? And now what we can do is go ahead and take the integral of this, right? Because that's going to be 4y cubed over 3 minus 12y squared over 2 plus 9y. And don't forget the plus c, because, right, it's an indefinite integral, right? So simplifying this, it's just 4/3 y cubed minus 6y squared plus 9y plus c. That's our answer. So let's box it. And then what was our method? Well, our method was first we expanded the expression, right? And then found the antiderivative. And how did we find the antiderivative, the integral? We use using the opposite of the power rule, right? So let's call it the reverse of the power rule. The reverse of the power rule. Okay, so that's the method we used for part A. All right, for part B. For part B, we have the integral from 1 to 2, so it's a definite integral of 2 to the power of 3x. So again, right now we don't have a method to do this, right? We don't have a lot of tools, but actually we can do this, right? We have this thing, our calculator. Our calculator can do the integrals for us. And since it's a definite integral, it will definitely do it for us. So I'm going to go ahead and go to F3 to calculate. I'm going to choose number 2, integrate. I'm going to put the function 2 to the power of 3x, right, comma the variable x, comma the start boundary to the stop boundary. That's going to give me the exact value. I'm going to use the diamond key plus enter to get the exact or approximate exact. So it's approximately 26.9303. I'm going to include units squared. Okay? So 26.9303. And then again, the description of our method, well, used calculator. Right? All right. Let's go on to part C. Part C. So here again, we have an indefinite integral, right? We don't have the boundaries. And here's our expression. This one, we're going to use the power rule again. So it's going to be 9m, add 1, divide by the power, plus 7m, add 1, divide by the power, plus c. Don't forget the plus c. And then we can simplify this. That's just negative 9m to the power of negative 1 plus 7/12 m to the power of 12 plus c. All right, there we go. And what was our method? We just used the opposite of the power rule, right, to take the antiderivative. Found the integral or antiderivative using the opposite of the power rule for derivatives. Okay, finally, part D. Here we have the integral of the expression square root of 9 minus x squared. So this is another one where we do not have the method, the tools right now, right? The multiple tools we have, we know that this is equal to 9 minus x squared to the power of 1/2 dx, right? But we're not able to do anything more with either of these expressions to find the antiderivative. But since it's a definite integral, we can use our calculator again. So I'm going to go F3, number 2 to integrate. 9 minus, let me write it as the square root of 9 minus x squared, comma, x is the variable, comma, the start is 0, the stop is 3. This time I'm going to do the diamond enter to get approximate from the beginning, and that's approximately 7.06858. I'm going to put units squared. Okay, and what was the method? Well, this one again we used our calculator. Alright, so that ends CPM Calculus Chapter 4, number 108.